Hey everybody, I hope that you are doing well. We are moving into week 3 of our distance learning. I think we have 6 weeks, so that means this is the halfway point. Last week we talked about hurricanes, and this week we're going to talk about tornadoes. This week, instead of doing all Edpuzzle videos that were documentaries and things like that, there were some things I wanted to explain myself. So what I want you to do is have up the Google Slides with all the keynotes or with all the slides, and I'm going to go over them with you. I'm then going to put this video on Edpuzzle so I can stop it and ask questions. You can answer those questions and I can give you a grade for watching this. So this would be kind of similar as to what I would go over in class. Being that we're from Oklahoma, we already tend to know a lot about tornadoes. So mostly this is me giving you kind of some basic general information, and we'll go from there. I think I can screen share on here and show the slides on my screen as well, so you don't have to look at my face the whole time. I'm sure you'll appreciate that. Couple things real quick. You guys did well with hurricanes. The last question on the Edpuzzle video said, why do you think hurricanes would be more destructive than tornadoes? Most of you got it. Hurricanes, wind speeds don't get near as high as tornadoes can, but they're huge. They can cover the size of an entire state. And they have those deadly storm surges. So hurricanes, on average, are more deadly than any tornadoes on record because they're just so big. A tornado can affect one neighborhood, whereas a hurricane can affect one entire state. Sometimes it'll devastate areas of 2 or 3 states if it's right along the coast. Next week, you will be doing some research on history making tornadoes and hurricanes, so you might keep that in mind as well. Okay, so I'm going to start with the slides. So I'm going to go over here to screen share and see if I can do that, if it does it. So I want to screen share. I guess this will work. All right, hopefully this is working. Otherwise I'm going to have to go back and record the whole thing. So the first slide is telling you the checklist. You're going to watch what you're watching right now and answer those questions. You're going to do the other tornado video on Edpuzzle. That'll be your 2nd grade. And then the Make a Vortex lab. That's only if you have the stuff. Please don't go out and buy this stuff. Don't risk exposure to buy something that's not necessary. This is a little activity I do every year in class. We use a water bottle, a little bit of dish soap, and a tiny bit of glitter, and make a tornado in a bottle. So if you have this stuff at home, I will post another video showing you how to do that, and I would love to see your results. Okay, let's get started here. So grab Toto. If you've ever seen Wizard of Oz, you'll get that. But tornadoes, the definition is a low pressure storm that usually forms over land. Guys, if it's over water, they call it a water spout. So tornadoes might turn into a water spout. If they move onto water, we'll call it a water spout. If it starts on water, we'll call it a water spout, but as soon as it moves onto land, it's then a tornado. We average around 800 tornadoes a year in the United States. The definition is a violently rotating column of air extending from a thunderstorm to the ground. That rotating column of air is called vortex. So that center, most violent part of air that everything spins around, that's the vortex. And that's a word you'll need to know. You're not going to be able to see the vortex until the debris gets sucked up in it. So the clouds, kind of spin down and things like that, but until that vortex hits the bottom and starts sucking up dirt and debris, then it's going to change color. Have you guys seen videos where you've seen like a white looking tornado, or you've seen this dark one like in the picture? I've even seen red ones because it has to do with the whatever it's sucking up. So Central Oklahoma is made of a lot of red dirt, red clay, And the tornadoes over there a lot of times tend to be more brown or red colored because of what they're sucking up. If you watch radar, they're indicated on radar by this thing called the hook. So if you look at that picture, you're going to see the little hook echo there, and it says tornado location. I'm going to see that. I'm not going to realize that's a tornado, but meteorologists are trained to be able to spot those things. So while they do have spotters out, they can also see them on radar. So tornadoes are basically a big energy release from a thunderstorm. So this thunderstorm basically gets so much energy that it starts spinning and rotating. And as it starts spinning and rotating, then that vortex starts forming until it reaches the ground. So we all know that tornadoes are dangerous. What makes them dangerous as compared to hurricanes is that their energy is concentrated in a small area. So up to about a Category 3 hurricane, they're pretty survivable because it's just sustained winds, but the winds only get up to about 100 miles per hour. It might rip a roof off, might do some things like that. But so long as you're hunkered down in your house, you're probably not going to suffer injury or death. A tornado, on the other hand, even the small winds can cause injury and death. So they are considered more dangerous overall just because of that amount of energy in that short period of time. So they're more dangerous to the area that they're in. We all know that we live in Tornado Alley. Well, what's that mean? If you look at this map, you're going to see where the highest amount of tornadoes are concentrated at, which comes right through Oklahoma. Now, if you remember the air masses we talked about last week, they all move different ways. So we have the continental polar coming in from like Canada that's pushing downward. We have the maritime air masses that are pushing from each ocean. And then we have the tropical ones that are pushing from the equator up. If you think about where all these air masses meet up, it's Tornado Alley. All the bad weather occurs where the air masses bump and collide and create those fronts. That was in the videos last week. So where those air masses bump and collide and make the fronts, that's where we get the most chaotic weather, which happens to be right where we live. We know that tornado season pretty much is from now till June or July, but most of us have probably lived in Oklahoma enough to know that they can occur pretty much any time if the weather's, in the right pattern there. They typically happen along cold fronts. And a cold front would be where the cold air pushes the warm air out. If you look at this picture over here, you're going to see the big cumulonimbus clouds. Those are your big storm clouds and kind of the way the rotation occurs. When a tornado forms and touches down, it could last anywhere from a couple seconds all the way up to hours long. There have been tornadoes on the ground for hours, but the average is about 5 minutes. But in that 5 minutes, a tornado can just do all sorts of damage. They can touch down and almost stay in one place or remain stationary, or they can travel more than 60 miles per hour. On average, they travel on the ground about 10 to 20 miles per hour, but just know that those can vary. Here's a aerial footage. I'll give you a second to look at this picture and see if you can find the tornado path. This is actually Moore, Oklahoma, from the 2012, I think, Moore tornado. So if you haven't seen it yet, look over to the right, kind of in the center of the screen on the right side. You're going to see this debris path. So out of this town, which you can see just in this part, this isn't a whole town, this is just several neighborhoods. It really only impacted this one part really bad. But all these people right here lost everything. They lost their homes, they lost cars, they lost pets, they lost businesses. Some of them even lost their lives. A school was decimated in this tornado, and I think like 6 children were killed at the school in this tornado. So you can see all these other people survived just this little tiny swath, but the amount of damage in that little tiny path was just incredible. The wind. The wind is a dangerous part of the tornado, if that makes sense, okay? This piece of wood was driven all the way through a tree. That was from a tornado. I have some other pictures here of tornado wind damage. So we've got the wood 2x4 straight through a roof. We've got a fork into a tree and bent over. The record in the telephone pole, it's pretty cool. You guys know that the rating system for tornadoes is called the EF scale. What you may not know is what that stands for, and that stands for the Enhanced Fujita Scale. It rates tornadoes based upon the amount and type of wind damage produced, and we're going to go through each one. I want to take a second here to say that if you, I'm not sure how old you guys are, it's Enhanced Fujita Scale. A long, long time ago, we had just the F scale, so they were F0, F1, F2, F3, F4, F5, Fujita Scale. The problem with the Fujita scale is the F5, which would be the largest tornado on the scale, topped out at 318 miles per hour. That was when they made the scale. There had never been a tornado even close to that. I think about 260 or 270 miles per hour was the closest it had ever been. So they put it at 318 miles per hour to top it out. If you guys have heard of the May 3rd tornadoes, that's May 3rd, 1999, I believe. The largest tornado ever in history hit Moore, Oklahoma. Wind speeds were measured at right about 321 miles per hour, which means that it blew the scale. So instead of adding a F6 to the scale, what they did is they created a new scale and called it the Enhanced Fujita Scale. So we're going to look at what the Enhanced Fujita Scale, or the EF scale, does and how it rates things. So we have the EF0. If you have to be in a tornado, hope you're in an EF0. That's winds 65 to 85 miles per hour. You might see some shingles get blown off, small things like that. But your house is going to stand, there's not going to be major damage. It's considered light damage. EF1, that's moderate damage, winds 86 to 110 miles per hour. With these tornadoes, you're going to see roof damage. You're going to see parts of roofs missing. Smaller trees might be uprooted and blown over. Mobile homes, your smaller single-wide mobile homes can be flipped over. That's why it's always recommended to get out of mobile homes. Flagpoles can bend, your brick mailboxes can be knocked over. In this photo, this house survived the higher end of the EF1 scale, and you can see that there's a window busted out. It blew the garage door open because of pressure. So there's some decent damage there. However, if you were in that home, you most likely survived. Your house can be repaired. Moving on to EF2, you're going to have 111 to 135 mile per hour winds. At this point, if you're in a single wide mobile home, it's gone. Permanent homes, that's brick and mortar homes, are going, could be completely shifted off of their foundation. Flagpoles collapse. Softwood trees, you can see the bark actually just be stripped off of it. This is a school in the picture that sustained damage with an EF2. You can see at this point the roof is completely gone. The windows are smashed. This is not repairable. This is a bulldoze it and build over type of damage. EF3, that's considered severe damage. 136 to 165 mile per hour winds. Your hardwood trees are going to be debarked, and all but small portions of houses are going to be destroyed. That's why they tell you to get into the smallest room at the center of your house. You can probably survive an EF3 if you do that. Your house will start ripping apart from the outside in. So if you look at this, I think it was a doctor's office or something like that, all of your outside walls have collapsed. There's no roof, but you could possibly be safe in the center of that building. It would be hard to tell. EF4, that's considered total loss. 166 to 200 mile per hour winds. That's complete destruction. Your total brick homes are gone. Large sections of school buildings, hospitals, things like that. You can see that car or Mustang. It's just destroyed. There's hardly anything left. If you look in the background of this picture, you can see a couple roof peaks where the roofs didn't quite blow down, but you can see where this house was, there's just absolutely nothing left. This is one that could easily cause someone to lose their lives if they didn't have a proper place to take cover. EF4 hit more just a couple years ago. The last really, the Joplin, I believe, tornado was an EF4. Maybe EF5, I can't remember. So on to the EF5. This is considered unfathomable damage. This is winds at 200 plus miles per hour. So what they did with this scale, instead of adding the EF6 to include higher speed tornadoes like what happened in 1999 on May 3rd and more, they updated the scale to where an EF5 is 200 plus. So if we had a 700 mile per hour tornado, it would also fall on that EF5 scale. You're going to see houses completely leveled off their foundations and swept away. This was a house in this picture, okay? It's flattened. Not only is it flattened, the stuff's not even there. So if we look back at this one, the wood is still there, their stuff is still there, it's just a big giant mess. This one, their stuff was found, I think it was like 3/4 of a mile away, is how far it swept this. These EF5 tornadoes are incredibly hard to survive if you are not in a proper shelter, either underground or in a safe room. Okay, so you're gonna see things completely leveled, swept away, automobile-sized missiles fly through the air in excess of 100 yards. That's insane. This is just a picture of a town that was hit by an EF5 tornado. That tornado traveled for nearly 22 miles on the ground and 95% of the city was confirmed destroyed. Okay, they estimated the winds were about 205 miles per hour. It was the first EF5 since they updated the Fujita scale, the F scale, to the EF scale. So if you look at this picture, you can see just the bottoms of trees are left. Some of the residents were lucky, like right there in the front of the picture, it looks like that gray building maybe didn't have quite as much damage as some of them on further back. As you go further back, you can see this tornado most likely strengthened and it just completely blew things away, just wiped it off the map. There's another aerial shot there. Watch versus warning. Guys, we live in Oklahoma. We have had blizzard watches and warnings. We've had severe thunderstorm watches and warnings, thunderstorm watches and warnings, tornado watches and warnings. We get about just all of the watches and warnings except hurricanes in our state. So I want to make sure you know the difference. A watch means conditions are favorable. It means kind of all the ingredients are there. It has the potential to become a tornado. It's not a tornado yet, but it could be. It's becoming a very dangerous situation. A warning, it means that's supposed to say event, sorry. The event is occurring. The tornado has been spotted. The funnel is coming down. The hook is on the radar. Okay, so if you've seen The Wizard of Oz, you might understand the little meme there. Tornado watch, you've got Elvira Gulch. She's the evil lady. She has the potential to be a witch, but she's not quite a witch yet. Okay, when she goes full on witch mode, then you're warning. Another way to think of it is this. I like this visual. Cupcake watch. So the cupcake watch is all of your ingredients are there. You have everything you need to make a cupcake. It just hasn't become one yet. Okay. Where you have your cupcake warning, there's your cupcake, you've got it. Okay, fresh out of the oven, all put together, all formed. So when we have a severe thunderstorm watch, that means we have all the ingredients to have a severe thunderstorm. The wind could pick up, we could have hail, lots of lightning, things like that. The warning is we've already got it. We have already met all the criteria that we are in a severe thunderstorm. It is happening. tornado watch. All of the ingredients are there. We're probably going to have some coming up fairly soon. We're going to have the cold front coming through. We're going to have wind. We're going to have the big storms. Okay. A tornado could form. That's our watch. Our warning is when the sirens start going off. We have a funnel. A tornado has been spotted on the ground. We have the hook feature on the radar. Take your tornado precautions. Okay, that's the end of my notes. So I'm going to stop share. And there I am again. I hope that this was informative. I hope it wasn't too awful long. It doesn't give me a time here. So I wanted to go over this with you because tornadoes are such a big part of Oklahoma day-to-day life. I actually had my safe room installed today. I'm so excited. I've never had one. I hate storms. Miss Philippi, the weirdo she is, loves them. She'll be outside like Joe Exotic, the Tiger King, taking pictures with a tornado before she'll go inside and take cover. I am not like that. As soon as they tell me there could be a tornado, I start cleaning out my closet. I have a backpack with first aid supplies and leashes and dog food and human food and all those things in case we were to need it in case of a tornado. So I try to be really prepared. I hate a lot of Oklahoma weather, but just remember, make sure to stay safe this storm season. I wanted you to have a clear understanding of the Fujita scale, the enhanced Fujita scale, and why it's enhanced. So I hope I was able to help you out there. I hope you guys are staying safe from the coronavirus and healthy. And I also hope that as we move into our storm season, it's been delayed just a little bit because we've had some kind of unusually cool weather, but it'll get here. It always does. Make sure you're staying safe. And now hopefully you understand a little bit more about tornadoes and how they form. Take care, guys. I miss you.